everyone, Gupta here, founder at 10x for the Kids and an official Guinness record holder for the youngest computer programmer in the world. And today we are going to be learning many things. We are going to be learning about first class objects, we are going to be learning about first class functions, decorators, closures. So we are going to be covering a lot of concepts. So without any delay, let's get started. Alright, so first we have first class objects, right? So we have first class objects. So what are first class objects? First class objects are those objects which can be assigned to a variable, it can be passed to a function as a parameter, and it can be returned from a function. So for example, take a number like 2. Now a number is a first class object. How? It can be assigned to a variable, very true. It can be returned from a function, right? So it can be returned from a function. So for example, return 2, right? No problem in this. And it can be passed to a function. So for example, this will take a value m and print m and call z with m. So no problem, sorry, not m, 2. So no problem with this also. We have a number, right? So we are able to assign it to a variable. We are able to return it from a function, and we are able to pass it to a function as a parameter, right? Next, what are first class functions then? We have understood first class objects. Now, what are first class functions? First class functions are nothing but basically first class objects that are functions. So basically, first class functions say that a function is a first class object. So how is a function a first class object? So it becomes a first class object when we are able to assign it to a variable, pass it to a function, and return it from a function. So let's create our own function. Let's say x. So now we have a square function that is taking in a number and returning its square. Alright, very cool. First we have to test it, like by assigning it to a variable. For a function to be a first class object, we need to be able to assign it to a variable. So let's create a variable x, right? So we have a variable x. Now we just have to assign it to a variable. So we can say square x equals to square, right? So if we call square over here and pass it 2, we can do x over here and pass it 2, and we'll get the same result. Why? Because this function over here is saved in some memory location, and square is just the name square. When we access square, is just pointing to the memory location where the function is saved. So when we say x is equals to square, x is basically pointing to the memory location where the function is stored. So basically x is this whole function now, and we are able to call it like we are able to call square. Printing, sorry about that. Alright, so now we are printing and we'll get what we expect, right? So we are getting 4. Oh, sorry, I cleared it. We are getting 4 and we are getting 4, right? Very cool. So we have seen that we are able to assign a function to a variable. Next, what we have to test is that we are able to pass a function to another function, right? So we have to see that we are able to pass a function to another function. So let's just say define this function is an operation on two function, and whatever function it receives, that function it will call on the number 2, right? and we are just going to print whatever result we get from the function that we pass, right? Now if we if we call operation on 2, right, and pass it square, so what will happen? Let's just see. So we are passing it the function square. It is receiving square in func, right? So it's receiving square in func, meaning it is happening func is equals to square. Func is equals to square is happening, right? So func is also pointing to the memory location where the square function is saved, right? So x is equals to 2. We are assigning the value 2 to a variable x, and then we are calling the function, right, that we pass, that is square in this case, right, and passing it x. It will return us the square, right? So 2 into 2 4, and that is being printed, right? So we'll get the operation done on 2, that is 4. Very cool. Very cool. Now now the third thing we have to test is that returning a function from a function, right? So instead of square, let's just make this a multiplication function. Let's say multiplication, right? Define multiplication. This will take in a number, and we'll change number into number later. We are going to define the outer function, right? This will take num1, this will take num2, right? So here the concept of closures we are going to see in a second, right? So now let's just see what is happening over here. We have outer, right? Great. That's taking number 1. We have multiplication, and that is taking number 2, right? And then we are returning num1 into num2, right? And we are in the outer function, we are returning multiplication. When we say multiply equals to outer 3, then this multiplication function is being returned. And when we call multiply 5, we are calling this function that was returned in this variable. So what is happening? 3 is being passed and it's being saved in num1. And but you will think that when multiplication is being returned, then the access to 3 will be over, because 3 is only accessible over here inside the function. Outside of this function, num1 is not accessible. So num1 will not be accessible over here. So when we call multiply and pass it 5, then when it returns num1 into num2, that will be num1 into 5, and num1 is not there. See, so we won't get a result, right? That's the normal thinking. But actually we will get a result. We are getting 15. Now how is that happening? So this is the concept of lexical scoping and closures, right? So lexical scoping basically defines a function's scope, right? So it's accessible scope. So for example, for this multiplication function, anything inside outer function and outside of that is accessible. For the outer function, anything outside of the outer function is accessible, right? Any global variables, anything else, right? Now, how closures work? Closures enable a function to access variables even after the scope closes. Now, what does it mean over here? Over here, when it returns multiplication, it has come out of the function, and num1 should no longer be accessible to this multiplication function, as the scope has been ended, and num1's value will be garbage collected automatically by Python, right? So logically, num1 should not be accessible anymore to the multiplication function, but it is accessible to the multiplication function as a closure over here is being created. How? When we have a function inside of a function and we are trying to access some variables that are present in the outer function, for example x is equals to 2, and we are just trying to print x over here first. So when this comes out of this function, when we come out of the outer function by returning the multiplication function, then the scope of x and num1 should automatically be removed. But it is not, because a closure is being created here, and for multiplication only, exclusively, x value and num1's value is accessible, that cannot be changed. So x value, when we come out over here, when multiplication is being returned and when we are saving it in multiply, then the definition for the multiplication function will look something like this. So our multiplication function, inside first there will be a print statement with 2, and second there will be a return statement with num1, whatever is passed over here, 3 is being passed, 3 into num2. So actually, instead of being returning print x and return num1 into num2, it's actually returning print 2 that it got over here and return 3 into num2, right? So that is happening. So x and num1 are exclusively accessible to the multiplication function, right? So this is the concept of closures. Then after the scope has ended, still the value of x and the outer variable's value is being accessible to the multiplication function even after the scope has ended, right? Very, very, very cool. So when we called outer 3, num1's value was now multiplication function that is being returned, it has access to num1's value. Let's just remove this x thing so that we don't get confused. So num1's value, that is 3, is accessible to the multiplication function. Now when we call multiply, that is basically the multiplication function saved inside of the multiply variable. When we call that and pass it 5, it will do 3 into 5, that is 15, right? So we get 15, right? So very, very cool concept of closures and all. I've explained it also in some other videos also, and if you have any doubts, please rewind or ask me in the comments below. All right, so now we are going to the concept of decorators, right? So we'll move on to the concept of decorators. So the concept of decorators is simple. It modifies the functioning of a function, you can say, right? So it modifies the behavior of the function. So it's written like at x, right? So let's just first create some code, and then we will like understand it. So for example, if you have some decorator called hello decorator, right? So you will have, if you have a decorator called hello decorator, you will first have to define it. So you will define hello decorator, right? So if you have a function like if you want to create a decorator hello decorator, you will first define it, right? And inside of this there will be nesting of functions in this, right? inner one. So this is a simple script over here. We have hello decorator, that will be our decorator. So we are going to be using it, always use the decorator on top of a function, right? So if you want to use a decorator, use it on top of the function on which you want to use it, right? So we'll say at over here hello decorator if we want to use it on top of on func to be used, right? Now this is this has an inner one function, right? And here a closure is being created because func we are getting over here, but we are using over here. So when inner one is being returned, it will still have access to func, right? And that cannot be modified, right? So outside over here also, this inner one function outside also over here will have access to func, right? And in this inner one we are printing hi before call, then we are calling the function, then we are saying printing after call, and then we are returning inner one, right? And then we are doing at hello decorator on this, and let's just try what is first. Let's clear the console and then let's run this. So we are getting hi before call, then the function is being run, this is the function, and then after call, right? So let's just understand what is happening. So let's just forget the decorator, or don't forget the decorator. So when you add a decorator on top of a function, then what happens in the background is that this func to be used is equals to hello decorator passing func to be used, right? So when I'm adding at hello decorator over here, this is what is happening in the background, right? So this is what is happening in the background. This statement is being executed, right, when I'm adding a decorator over here, right? So this is basically how is it modifying the behavior when adding hello decorator over here. So first, to show you that this is only happening, I'm going to be removing this, right? And I'll be just adding this over here, right? So this will give us the same result, right? So we are getting the same result over here. Okay, now let's just see what like how is this happening. First let's see how is this happening. So how is hi before call and after call coming? So when we have func to be used, right, this is being passed to the hello decorator. So function to be used is being passed to the hello decorator, it's being received as a func, right? And then there's this inner one function. Now over here, whatever function this function is doing, that will be executed over here. Now we have the power, what are decorators used for? To manipulate the behavior or add to the behavior of the existing function. So we have this existing function. Now we want to add to this something. So for example, we wanted to add this print statement and this print statement to it. So instead of changing this, for example, we have 100 functions, right? And we want to add this print statement after the function behavior is being done, and this print statement before the function behavior is being done, right? And we have 100 functions. So we have two options: either write these print statements in all the 100 functions, or the second option is to create a decorator to modify the behavior of all the 100 functions. The easier way is to create a decorator, right? So I've told you the usage of a decorator, that it's used to modify the behavior of usually multiple functions. So you create a decorator to usually modify the behavior of multiple functions, right? So if you have some repetitive code to add that, you use decorators in Python, right? Now this func is accessible to inner one, right? So this function is being it's accessible to inner one, and it's when inner one is being returned, it's not changeable. It's exclusively accessible to inner one even after the function has ended, right? So even after the function has ended, in the func will be accessible to inner one, right? This will print hi before the call. It will do whatever our function was doing, and it will print after call, right? So the what was happening again, this was happening. Oh my god, I'll have to type it once again. So what was happening, func to be used is being modified, so it is being overridden by hello decorator, right, and passing it func to be used, right? So this is what is happening. Func to be used is being passed to hello decorator. We are getting this new inner one function that is being assigned to func to be used, right? This is happening when we are adding at hello decorator on top of the function. Alright, so now on the behavior of decorators, we have gone very deep into the behavior of like in the functioning of the decorators, right? So now this was the decorator. Now what if the function was taking an argument? What if we were taking an argument over here? Then what we will do? For example, this takes in an argument a, right? So this takes in an argument a and it just prints a, right? So very simple. So we will pass this hi, right, when we are calling it. Now we want to modify the behavior of this function. So we want to add these two print statements before and after it. So to add this, what you will do, in inner one also you will accept some arguments, but now the problem arises that you don't know the number of arguments this function is taking. So what can you do? So there's these things called star args. They are used when you don't know the number of arguments that are being passed to the function. So for example, if we are passing 50 arguments and we don't know that, then what we can do, we can say star args. So those 50 arguments will be added into a list, right? So they will be added into a list, and args will be that list. So basically when adding star args, args is a list of all the arguments, right? When you don't know the number of arguments. Now it's over here, it's not compulsory that we say we only have like one argument. We have maybe we have a and b, we are printing a and then we are printing b, right? This star args is tackling. But what if we did b is equals to hi, comma a is equals to hello? So now args will be in a particular order, but over here we are not meeting that order, right? And we are giving a named argument, right? And star args only takes arguments that are being passed, right? And it's not tackling a named argument. So what we can do, we can say star kw args. Now this is a convention to say this is args and this is kw args, KW stands for keyword, and args stand for arguments. So over here, this is arguments and this is keyword arguments. So you can say this anything you like. You can say this X and Y, but it's a convention to name it as args and KW args. Now, what is star star doing? Over here, a list was being created. Over here, from star star, a dictionary will be created, right? So a dictionary will be created with B is equals to hi and A is equals to hello. So in KW args, so when this is happening, args will have, when you are passing normal values, it will have hi hello, and when you have keyword arguments, what will happen? When you have KW args, it will be B hi and A hello, right? So this will be the keyword arguments, and args I already showed you, right? Very cool. Next, we are going to say star args over here and star KW args. Now you might be thinking, the list has already been created, right? So, and the dictionary has also been already created. So why aren't we just passing the list itself or the dictionary itself? Why we have to give star once again, right? So it's not that we have to match the name. It's not that reason. The reason is that this function is not taking in a list or a dictionary. It's taking in separate values, right? So this is taking in separate values, our function. So this star over here is known as the spread operator. So the star is very multi-purpose. It is used while accepting arguments. It's also used as a spread operator. What is the spread operator doing? For example, if you have an arguments list with hi and hello, and you say that some function func, and we want to pass it star args. So what will happen over here? What you are actually doing, you're passing it hi comma hello, right? You get it? And now if you had KW args and this B is equals to hi and A is equals to hello, right? So then when you're doing star KW args, what is actually happening? What is actually happening is B is equals to hi and A is equals to hello, right? So this is what is happening in the background, right? So when a function is working with arguments, you will take the arguments as a list or as a dictionary, and then you are going to spread those arguments out by using the same star. Very cool. Now we are going to go a little further. We have used one decorator on a function. What if we want to use two decorators on the same function? Okay, so we'll write a simple example for this. Alright, this is, let's say this is a num function, and this is, or should I just drag and drop the code in? Let me just pick up the code, right, so that it will be easier. Right, so this is the code over here. Now, oh my god, I forgot, we'll get indentation errors in this. Let me just try and run this. Oh no, we are not getting indentation errors. Alright, very cool. So let's just pretend we didn't see the result, right? So now what is happening over here? We have decorator 1, it has the inner function. it is saving whatever the function is returning in an x, and it's returning its square, right? So decorator 2 is returning 2 times the number, right? Next we have the num function that is returning 10. On that we are applying decorator, our decorator, and our decor 1, that is this, and then we are reversing the order also. So order matters a lot. Note, order matters a lot. What will happen while this is happening? On num, first at decor will happen, right? So when at decor will happen, it will return a function, right, that will return 20, because 10, that will return 20. Why? Because 10 into 2, that is 20, right? So func will be passed, inner function will get this decor will get func, right? Inner function will save the value 10 in x, and it will return 2 times x, that's 20, right? So when applying this will give us a num function that will return 20. And now on this whole thing, decor 1 is being applied. So the value that is being returned, that is 20, from this is being saved in a x variable. Its square is being returned. So 400 will, 20 square is 400, right? So this whole thing will basically be a num function that will return 400. And this, in this, what will happen? The first the square will happen, and then the multiplication will happen. So when applying decor 1, it will get 10. 10 square is 100, right? And then decor will get the value 100, and 100 into 2 is 200. So when we call num, we'll get 400, and when we call num2, we get 200. So if we just go run this, we'll get 400 first from num, and from num2 we'll get 200, right? Very cool. And this was the concept of decorators also. These are all the concepts we have covered, all the concept in the all the concepts in this video. I hope you guys liked the video. If you did, don't forget to smash the like button, and I will see you in the next one.